Hi, I'm Brandon Polak.
Hi, I'm Lena Kendall.
Hi, I'm Adam Paul.
Our project is an interactive soundboard incorporating the Daft Punk song Harder, Better, Faster, Stronger. Using Max MSP and the Arduino board, different buttons and knobs correspond to the different sound clips from the song and different effects such as tempo or pitch.
When you connect a PlayStation 2 controller to Max MSP, every button has a number, which is its ID, and each ID has a value to go with it. When we unpack the HI, or Human Interface object, we get two numbers. The first is the button's ID, the second is its value. Let's use triangle for example. The triangle button has an ID number 4. Now when it's pressed, the button has a value of 1. When the button is no longer pressed, it has a value of 0. Each button is the same with the exception of the D-pad, which has different values for left, right, and neutral, 0, 255, and 127 respectively. Here's how we implemented this. Let's use the triangle again for example. Here we see the roots for IDs 4, 19, 20, and 12. That's triangle, up and down, left and right, and 12 is select. We also see 3 gates, 4 buttons beneath those gates, and 4 messages, all with different sound files connecting to an SF play object. When an ID of 4 is sent from the HI to the root, it outputs to a greater than object. This is saying that when ID 4's value is greater than 0, or triangle is being pressed, it plays the SF play object for that button. Now the other IDs, 19, 20, and 12, affect which sound will be played through triangle's SF play. We see 4 messages. Each one corresponds to a different sound that triangle can play. Now let's follow the route. The message that 4 has a value of 1 is sent to the first gate. The first gate is controlled by the select button with the ID 12. When 12 has a value of 1, or select is pressed, the gate switches to a button which sends a bang message to the message open more than high.wave. Otherwise, it sends it on to the next gate. The next gate is controlled by the value 20, or the up-down arrows. When 20 has a value of 0, up is pressed, the gate switches to a button which then goes to the message open workithhigh.wave. Otherwise, it goes on to the next gate. Now the final gate is controlled by ID 19, the left and right arrows. When 19 has a value of 0, the gate switches the route to the message open more than.wave. Otherwise, it's sent to the message open workit.wave. In this way, the triangle button, when pressed in different combinations, can play 4 different sounds. We repeated this 7 times to accommodate the 4 shape buttons and the 4 trigger buttons. We also added the backbeat to accompany you while you play. As you can see again, we used a root object, this time taking inputs from the start button, ID 13. The load bang object sends the messages open backbeat.wave and loop 1 to the SF play as soon as the patch begins. This tells the SF play to play the backbeat looped infinitely. The gate allows the start button to set the backbeat in a constant state of play, rather than having to hold it for the backbeat to continue to play. Our Arduino setup features 2 knobs connected to analog pins on the Arduino board, importing them using the P Arduino serial reader object and 2 objects entitled RA3 and RA4, one for each pin. The different routes specify different knob positions. The left knob controls the pitch of the sound clips, and the right knob controls the tempo of the backbeat.
There you go.